Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can add, subtract, multiply, and divide rational expressions. Now, if you want an in-depth explanation of all of these, please check out some of the previous videos. But for the sake of this video, we're just going to briefly go through an example of each operation on rational expressions, and what we can do to relate those. So we're going to get started by talking about multiplying rational expressions here. So we're going to start by multiplying this rational expression. Now, anytime we multiple rational expressions, our very first thing that we want to do is we want to factor the top and the bottom of each fraction. Okay, so that's what we want to do first. Factor it out, and not just like kind of factor, but factor it completely. Break down those numbers till we get their prime factors. Everything needs to be broken down and written out so we know what do we have. So let's take a look at this first one. Remember, when it comes to factoring, if I have one term that I'm trying to factor, for example, one like this one up here, what we're going to do is we're going to break it down, and we're going to have the numbers that it breaks down into multiplied together. So for example, with this one here, we're going to multiply it out 2 times 3 times x. And that's what we're going to have on the top there. Now, we have no other single term pieces, so then we have two term pieces. The very first thing we want to do is check to see if it has a greatest common factor. So looking at this one on the right here, this x minus 9, that does not have a greatest common factor, so we're going to leave it there for a second. The one on the left does have a greatest common factor, and that's going to be a 6x. So we factor out a 6x, and we end up getting 6, and we end up getting x plus 6 left over. Now, I know you may be thinking to yourself, this is factored, but is that 6 broken down completely? That 6x goes back to that one with only one term there, and that actually can break down into 2x and a 2, a 3, and an x. So what I'm going to do is I'm actually going to break it down that way. We're going to change that into that 2, that 3, and that x, just so that we have it broken down as much as possible. Now, if it doesn't factor with the greatest common factor, we check to see if it is a difference of squares or a difference of cubes. Now, looking at this problem here, x minus 9, well, x is not a square number, even though 9 is. So that is not a difference of cubes. If it doesn't have a greatest common factor and it's not a difference of squares or a difference of cubes, we're going to say that it cannot be factored pretty, and we're going to leave it the way that it is. Now, the last thing that we're going to see is we're going to see 3 terms, and those we're going to use the x method on. So as we're using that x method, remember what that means is we're going to take our first times our last term. So if we're setting up our x method for this one here, we've got a negative 54 on top, a negative 3 on the bottom, and we want two numbers that multiply to negative 54 and add to negative 3, and that is going to be a negative 9 and a 6. So then we can write this in factored form as x minus 9 times x plus 6. Beautiful. So then we have those all factored out. That's step number 1. Step 2 is we want to combine them, and all that means is we want to write the top all on the same top line and the bottom all on the same bottom line. So let's do that. We've got an x minus 9, an x plus 6, we've got a 2, we've got a 3, we've got an x. All on top on the bottom here, we've got a 2, a 3, an x. We've got an x plus 6, and we have an x minus 9. Beautiful. Once we combine them, our third step is to cancel. Now remember, we are not eliminating or getting rid of these, but we're simplifying them down to 1. So if we have the same thing on top and bottom, anything divided by itself is 1, so we can simplify that down. So I have a 2 on the top and bottom, a 3 on the top and bottom, an x on the top and bottom, an x minus 9 on the top and bottom, and an x plus 6 on the top and bottom. Whoa, we have nothing left. If you have nothing left, or if you have something left after we cancel, the last thing is to write that simplified form. And that simplified form in this case is whatever's left on top and whatever's left on bottom. In our case, because we canceled everything out, it simplifies down into 1. However, if we still had an x plus 7 on the top, then it would be x plus 7. If we had a 3 on the bottom, it would be x plus 7 divided by 3. Whatever is left on top stays on top. Whatever's left on bottom stays on bottom. If everything gets canceled on either the top or the bottom, then we write a 1 there. In this case, where everything got canceled on the top and the bottom, we know that it's just equal to 1. And that is the process that we follow to multiply rational expressions. Now, for the sake of the other videos, I will not be writing, or the other examples, we will not be talking about how we can factor them. We will just say we need to factor it. So let's go ahead and move on to dividing rational expressions. Now, dividing rational expressions is very similar to multiplying rational expressions. The reason why is when we divide fractions, people don't like to divide fractions because A, people hate dividing, and B, people hate fractions. So why would we do the double doozy? So what we're gonna do is we found that if you divide by a fraction, that's the same thing as multiplying by its reciprocal. So when we divide rational expressions, the very first thing we're gonna do is change it to a multiply by that reciprocal. So we want to change it to a multiplication problem. So we're going to copy the first one the exact same way that it is. And there are two like phrases that people have heard before that kind of go with this idea. Some of them are called keep, change, flip, where we keep our first fraction, we change the sign in the middle, and then we flip our second fraction. The other phrase is flip the action, flip the fraction, where we change our sign and then we change the fraction afterwards. But what we're going to do is we're going to keep that first one the same. Over 6n plus 20. We're going to change our action to a multiply and then flip our fraction over. Okay, now that it has been flipped over and we have a multiplication problem, then we can just follow the steps of a multiplication problem where we will factor out the top and the bottom. Then once we factor that out, then we are going to, we factor, then we combine them together. After we combine them together, then we are going to cancel out what's in common on top and bottom. Oof, my struggling is spelling. Wow, my spelling is struggling. We are going to cancel out what's on the top and bottom, and then last write that simplified version. So let's go ahead and walk through those steps here with this problem. So we have multiplied by its reciprocal. Now we need to factor. Remember, if there are two pieces, we try to find the greatest common factor. So that is going to be these other three here. And so 6n plus 2, we'll find our greatest common factor is 2. So we end up with a 3n plus 2 on the bottom. Then we have this 18n plus 60. Well, a 6 factors out of both of those, and we end up getting 3n plus 10 right here. And this 6 we can actually factor down, remember, into a 2 times a 3. And then on the bottom here, we've got a 6 that factors out and an n plus 4. And this 6 can also be changed to a 2 times 3. And then this top part here, we do need to factor, and we're going to factor using our x method. So I need two numbers that multiply to negative 32 and add to negative 4. And that's going to be negative 8 and negative 4. And so we end up getting n minus 8 and n minus 4. Awesome. Then our third step is to combine these all together. I'm going to do that in black here. And so we've got an n minus 8 combined with an n minus 4 times a 2 times a 3 times a 3n plus 10. And that whole thing is going to be over 2 times 3n plus 2 times 2 times 3 times n plus 4. Okay. Oh, I wrote this wrong here. This is a plus 4. There we go. Because negative 8 times negative 4 is not negative 32. It's positive 32. Oof, glad we caught that mistake early. Okay, so then now that we have that all combined, we are going in our cancel step here, where we take anything that's both on the top and the bottom, we get rid of it. So there's a 2 on the top and bottom, there's a 3 on the top and bottom, there's an n plus 4 on the top and bottom, and I think that's it. So then in the previous video, we talked about how, or in the previous example, we talked about how we can simplify it. And if there's nothing left, we write just a 1. But if there is something left, we're going to write that. So in this case, on the top, I have an n minus 8 left. And I also have a 3n plus 10 left. On the bottom here, I've got a 2 left. And I have a 3n plus 2 left. Okay. So then what we want to double check is make sure it's simplified as much as it can be. I am not going to require you to multiply these back out. We can actually leave our simplified answer just right here. If you would like to multiply it out and get it into a expanded polynomial form, that is totally fine, but I'm happy if you want to leave it here in factored form. So again, dividing polynomials is a lot like multiplying. When we multiply, we factor, we combine, we cancel, and then we simplify. When we divide, we flip the action, flip the fraction, or we change it to a multiply and reciprocal. Then we factor, combine, cancel, and simplify. So multiplication and division work hand in hand that way. The next two examples that we're going to talk about are adding and subtracting, and those are the last things we're going to talk about. They kind of follow a different sort of rules here, or a different sort of pattern. So what we're going to do when we add or subtract rational expressions that's different than what we do when we multiply and divide is when we add and subtract, we are only going to start by factoring the bottom if it needs to be factored. The reason why is what we have to do, this is kind of like a subpoint, is we have to get a common denominator. Remember, we can only add fractions if they have the same number on bottom. A common denominator. So to get that common denominator, that is going to happen by factoring just the bottom and then asking ourselves, what does it need? What is it missing? Okay, so those are the two steps we're going to follow there. So let's go through that first step here to find common denominators. Now, before we do want to check, do I already have common denominators? In this case, we've got an x squared minus 1 and an x plus 1. Those are not the same denominator, so we want to find that common denominator. Now, the reason why we factor out the bottom, it's not that that's the only way to do it, but it's because we want to multiply by the least common multiple, which means I want to do the least amount of multiplying that I have to. So when I go to factor this left side out here, this is actually going to be that 2-piece or a difference of squares. And so it actually factors into x plus 1 and x minus 1. And then my top stays exactly the same as it was before. And we're going to add that to -1 over, now does our bottom of this one factor out? Well, x plus 1 is as simple as it gets. There's nothing in common that we can factor out other than a 1. It's not a difference of squares, things like that. So it stays at an x plus 1. Now, we want to ask ourselves, what does it need? The one on the left has something that the one on the right doesn't. The one on the right still needs an x minus 1. So what we have to do is get that common denominator by multiplying by that x minus 1 on the top and on the bottom. So when we multiply by that, the left side's going to stay the same here. However, we can always multiply both sides by something. And we get x plus 1 times x minus 1 plus -1 times x minus 1. Over x plus 1 times x minus 1. So after we get that common denominator, here we are, common denominators. Our second step is to combine the fractions. So as we combine these, we want to just rewrite the top exactly as it's written with that plus sign in there. So we've got -2x squared plus -1 times x minus 1 all over x plus 1, x minus 1. Now, the reason why we have to get a common denominator is because then our denominator stays that same thing. And so then after we've combined those, then we want to expand the top if needed. Expand and simplify the top. So what that means is if I have any multiplying that needs to happen, I'm going to do it. If I have any subtracting that needs to happen, I'm going to do it. Everything's going to get combined as much as it can on top here. So my -2x squared is going to stay the same. And then I've got this plus a -1 times x and a -1 times -1. So what we're going to do here is we're actually going to distribute that. And we're going to end up giving ourselves a -1x plus 1. And that whole thing, notice how that negative got distributed, is going to still be over x plus 1, x minus 1. Okay, so then once we get to this point where it's expanded and simplified on the top, our fourth step is to try to factor the top, if possible. So we're going to try to factor this. It has 3 pieces, so I'm going to try using the x method. So we're going to multiply. Remember, if there's a number up front, we take that number and multiply it by the end. So we want 2 numbers that multiply to -2 and add to -1. Well, that's actually going to be -2 and a 1. So this factors out into x minus 2 times x plus 1 over x plus 1 times x minus 1. Now, our fifth step after we factored out the top is we want to cancel, if possible, just like we did before. And in this case, we have an x plus 1 on the top and bottom. And so step 6 is to simplify. And so once those get simplified out, we just write what's left over, which is x minus 2 and x minus 1. And that is our solution there. So notice here how when we add or subtract, we have a few further steps. We find a common denominator, because really when we were doing this before, we factored the top and bottom, combined them, canceled them, simplified them. Here we have to find a common denominator and then combine them and then expand them if there needs to be expanding, multiplying, things like that. Before, we didn't have to multiply. But when there's an add and subtract sign, we do actually have to combine. We have to multiply out, combine, and then try to factor. So we really have to do quite a few more steps here. However, the beautiful thing is, if you know how to add rational expressions, you also know how to subtract them. The biggest difference between adding and subtracting is that subtraction sign applies to everything that happens on the top of our right fraction. Okay, so it doesn't just go to the first term, but it goes to everything. So let's go ahead and run through the steps that we have here to subtract or add a rational expression and work through it. So our very first step is to find that common denominator. Now, if they don't immediately have it, remember what we're going to do is we are going to factor out the bottom, and then we are going to figure out what it's missing. So let's factor out the bottoms here. We've got 3x minus 2. This bottom piece we can factor using the x method. Two numbers that multiply to negative 12 and add to 4 is 6 and negative 2. So we get an x plus 6 and an x minus 2 minus 5. We can factor out a 2 here times x minus 6. Beautiful. Now we need to ask ourselves, oh, that's going to work out real pretty here. I'm going to change this problem just for the sake of making it easier on us, because do you see here how we've got an x plus 6 and an x minus 2 and then an x minus 6 on this other side? What that means is that we're going to end up needing to multiply both sides by something, and that sounds by a lot, and that's going to be a lot more work for us. However, if this is a minus 4 here, that changes this to a negative 6 and this to a positive 2, and all of a sudden our workload just limited. So make sure that you are keeping those signs consistent there as we're doing that. So I'm going to change that. We did just change that x squared plus 4x minus 12 to an x squared minus 4x minus 12 just to make the problem easier on us. It didn't change much but the signs in our denominator. But then when it comes to asking ourselves, what does the left one have that the right one needs? Well, then in this case, all it is that x plus 2. Otherwise, before it would have been an x plus 2 and an x minus 2 and an x plus 6, and that was going to make this problem a lot more complicated. Then once we figure out what the right fraction needs, we have to ask ourselves, what does the right fraction have that the left side doesn't? And in this case, it's actually a 2 on the bottom. So we do need to multiply both the top and the bottom of this fraction by 2. And as we multiply that out, what we can do is we then get to that point where we're on step 2 here, which is to combine our fractions together. And so we do need to combine things together. And so first we want to write out what these new factored forms are. So we've got 2 times 3x minus 2 over 2x minus 6, x plus 2, minus 5 times x plus 2 over 2 times x minus 6, x plus 2. Woof. So then we're going to combine them together. And again, all that step means is that we're going to write the whole top row together. So 2 times 3x minus 2 minus 5 times x plus 2 all over 2 times x minus 6 times x plus 2. Now, after we combine them, what we're going to do is we are going to multiply and simplify. And what that multiply and simplify step means is that's where we do that distributive property and then combine like terms. So I'm going to distribute both of these things here, and I'm going to distribute that negative with that 5 as we use that distributive property there. So we distribute it and we get 6x minus 4 minus 5x minus 10 all over 2 times x minus 6 times x plus 2. Then after we've multiplied, we then want to do the simplifying step where we combine things that are alike. And so in this case, as we combine the things that are alike, we get a 6x minus 5x, which is x minus 14, all over 2 times x minus 6 times x plus 2. Now, after we multiply and simplify, then we want to do that factoring of the top. And in this case, if we look at x minus 14, that doesn't factor. So once we have it factored, then our fifth step is to do our canceling. And so we want to ask ourselves, is there anything in common on the top as we have on the bottom? And you'll notice that there is nothing in common between that top and bottom there. So nothing cancels out. And because there's nothing that cancels out, then our last step is to make sure that we write out that simplified form. And when we're writing out that simplified form here, because nothing canceled out, this is our simplified form there. So the biggest thing about subtraction is making sure that we use that subtraction sign the way it is. A really easy way to make sure that we're applying that subtract is when we write it in that combined form to just, when we do our distributive property, make sure that we're doing negative times that whole thing. But that is the biggest mistake that we see. If you have any questions, feel free to reach out, but that is how we can add, subtract, multiply, and divide rational expressions.